Hello, BES 485. My name is Julian, and I did my conservation case study on the leatherback sea turtle, or Dermochelys coriacea. So, a little bit of an overview. The leatherback sea turtle is the largest turtle species in the world, as well as the largest distributed turtle species globally. And what makes them so unique is that they do not possess a hard outer shell or scales like other sea turtles. Rather, they have a tough and leathery exterior, which is where they gain their name. These turtles inhabit tropical and temperate waters in the Pacific, Atlantic, and Indian Oceans, and the largest nesting site being located on the coasts of South America, Guinea, and Papua New Guinea. They are also incredibly strong swimmers, and they can dive as deep as 4,000 feet and hold their breath for 80 minutes or longer. They also lack the chewing plates in their mouth. Rather, they have pointed tooth-like cusps and sharpened edged jaws, so their diet consists of soft-bodied organisms such as various cnidarian species like jellyfish and siphonophores, as well as salps, which are barrel-shaped planktonic tunicates. And once they reach adulthood, they can get up to 4 to 8 feet in length and range anywhere from 500 to 2,000 pounds. And to give a comparison, they are pretty massive relative to both humans as well as other common turtle species such as the loggerhead turtle and hawksbill turtle. Alright, so a little bit about their nesting and migration. They can span 3,700 miles each day between breeding and feeding, which is longer than any other sea turtle. During nesting, adult females will come up from the water during the night, and once they are on shore, they will dig large body pits for their eggs. And adult females can produce 3 to 10 groups of 60 to 90 eggs during reproductive seasons and return every 2 to 3 years to the original nesting site. However, the success rate of a hatching nest is only 50%, considering many nests are destroyed by predators and very few younglings will actually make it to the water once they are hatched. The main threats to the leatherback population are egg consumption, which are seen as a delicacy in some areas of the world. Also, plastics in the water gets mistaken for food, such as jellyfish, which causes them to suffocate. The leading threat to population decline is bycatch fishing, which is when they get caught unintentionally in commercial fishing nets, which leads to suffocation, drowning, and death. Currently, there are federal policies put into place to combat the amount of bycatch fishing conducted, such as the Magnuson-Stevens Fishery Conservation and Management Act, Marine Mammal Protection Act, as well as the Endangered Species Act. And underneath the ESA, NOAA Fisheries, conducts a critical habitat designation which determines which areas have the critically endangered populations. To name a few, the U.S. Western Coastal Region and the U.S. Virgin Islands are listed as critical habitat zones. Extending beyond just U.S. policy, the Inter-American Convention for the Protection and Conservation of Sea Turtles, otherwise known as IAC, is a multinational treaty serving to promote the protection and conservation of endangered sea turtle populations. As far as conservation efforts, statistical and data collection models have been implemented along the western coastline of South America to predict turtle shifting distribution in order to limit the amount of bycatch that is being conducted during commercial fishing seasons. And this model was able to predict the turtle intensity monthly by using multiple covariates such as sea depth, sea temperature, and chlorophyll concentration as potential indicators of population presence. And despite bycatch being the leading cause of population decline, leatherback sea turtles face mass amounts of bioaccumulation as well from various toxic metals and chemicals, specifically mercury and selenium. And researchers have begun to assess the impacts of these toxins. Trace amounts of these chemicals due to anthropogenic causes such as fossil fuels and metal processing can be found highest in leatherback livers. Additionally, researchers have done studies of collecting prey items such as jellyfish and analyzing mercury and selenium levels within those to indicate the threat of harmful levels that have been accumulated. Mercury is especially harmful as it develops into a neurotoxin, whereas selenium manages to detoxify mercury levels within the turtle's muscular and skeletal systems. These levels can have physiological harm and can have effects on longevity and reproductive success rates, especially when hatching and nesting eggs. Leatherbacks have been shown to have lower hatching rates than any other sea turtle, and this is due to the amounts of mercury being ingested, as well as the lack of dietary selenium needed to conduct mercury-selenium detoxification. Mercury and selenium levels were measured in nesting females in Florida, and both dietary selenium as well as the liver selenium to mercury ratio were low, which contributed to low hatching rates. Through bioaccumulation, whether anthropogenic or not, it is a cause for concern for a critically endangered species such as the leatherback, considering chemical concentration levels increase as they age, which leaves them severely impaired. Leatherback sea turtles are, however, still an integral part of various cultures globally, including the indigenous people of the K Kecil Islands, also called the Nufit people of Indonesia. They serve as the most important cultural species to the indigenous communities and are used for various ceremonies and rituals. They are hunted in the region for these purposes as well as for food. And conservation groups are working with the new FIT to integrate scientific methods of protection and conservation without dismantling decades of culture and tradition and identity. So thank you for watching, and these are my sources.